Hi 8th grade, this is Miss B here with Monday's lesson. Let's start by going over our do now. So the do now for today says the two rectangles below have the same perimeter. And we're given two rectangles. Remember, the measurement when we're looking for perimeter is the distance around the outside. So we're not calculating the area, which has to do with the number of square units on the inside of the shape. We are calculating the outer measurement. So the formula for perimeter says that we double the length and add that to twice the width. So we know that sides that are across from each other on a rectangle are the same measurement. So in the first rectangle on the left, if we have a length of x plus 12, the opposite side is also x plus 12. If we have a width of 2x plus 20, we have 2x plus 20 on the opposite side. So we are asked to solve for x. So if the perimeter of these two rectangles is the same, then we can set each rectangle equal to one another. And we're going to get something that looks like this. So what I have set up in the green represents the perimeter of the first rectangle. And what I have set up in the blue represents the perimeter of the second rectangle. So again, if we're solving for x and we know they have the same perimeter, then we would set the expression for the perimeter of the first and second rectangle equal to each other. So now this is turned into a multi-step equation, and our goal is to solve for x. We're going to begin by getting rid of these parentheses by applying distributive property. So take a moment to distribute both on the left and on the right side of the equation to get rid of the parentheses. So 4x plus 40 plus 2x plus 24 equals 2x plus 16x minus 8. The next step is to combine like terms on both sides of our equal sign before we start using inverse operations. So we have 4x plus 2x, which gives us a 6x. We have 40 plus 24, which is 64. On the right-hand side, we have 2x plus 16x, which is 18x. And we have our constant minus 8. So now that we can't simplify anything on the left or the right, we're going to start using inverse operations to get our variables together on one side and our constants on the opposite side. So I'm going to start with the variables, and I'm going to take the one with the smaller coefficient to the one with the larger to avoid dividing by negatives as my last step. So since 6 is less than 18, I'm going to subtract 6x on both sides. I'm going to go into part B, but I'll erase it when we're solving the work for that actual part. Make sure that you leave enough space for you to actually show the work in part A. So 6x minus 6x gives us 0, so we're going to bring down what we have left on the left, which is 64. 18x minus 6x gives us 12x, and we're going to bring down the constant that we have on the right. All right, so now that our variable is on the left, we're going to bring our constant to the opposite side by adding 8. This is going to cancel out, and we're left with 72 is equal to 12x. And our last step in solving this equation is the inverse of multiplication, which is division by 12 on both sides. So our final answer is that x is equal to 6. Take a moment to finish writing up any steps that you have missed or that you didn't get to write down. And when you unpause this video, the section will be erased so that we can do part B. So we found that x is equal to 6, and in part B we are to find the actual perimeter of one of the rectangles. So now that we have a value for x, we're going to substitute it back into one of these rectangles, and we'll get the actual perimeter. It doesn't matter which you substitute, the first rectangle or the second rectangle, since they're equivalent to each other, I'm going to substitute into both so that you'll see that they do in fact have the same perimeter. So the expression that represented this first rectangle after we combined all our like terms was 6x plus 64. The expression that represents the perimeter of the right rectangle was 18x minus 8. Right, so we have rectangle 1 and rectangle 2. That's not a 2, that's a 2. So I'm going to substitute x to solve for the actual numerical value of the perimeter. So we have perimeter equals 6 times whatever x is plus 64, and we just solved that x is 6. So now let's simplify this expression. So perimeter is equal to 36 plus 64, which is 100. Rectangle 2, the expression is 18x minus 8 for perimeter. And we're going to substitute 6 once again and subtract 8. 18 times 6 is 108 minus 8, and 108 minus 8 again gives us a perimeter of 100. So because we were told that the perimeter of both rectangles are the same, you only needed to substitute x into one of these to find that the perimeter is equal to 100. So that's what we have for our do now. What we're doing today is continuing solving algebraic equations. Those are the ones where we solve for an actual variable that's in our equation. And today's focus is on equations that have fractions as constants and fractions as coefficients. So we're going to take a look at 3 or 4 examples together right now. We're going to look at 4, and the rest of the class you'll be practicing independently. Let's take a look at example 1. Simplify the expression below. This is wrong. Please cross out expression if you have that on your handout. It should say equation. That's a terrible mistake. Let me go fix that on your handout right now. Okay, so your class handout for today will actually have the word equation written on it. So what we're going to do in order to eliminate these fractions and turn it into a multi-step equation is find the least common denominator in our two fractions here. So we have 3/4 and 2/3. The least common multiple of 4 and 3 is 12. So what we're going to do to each side of the equation is multiply our numerators by the least common denominator, which again is 12. So remember, when you're multiplying by a whole number, with fractions you do numerator times the numerator, denominator times denominator. So we have 12 times 3, which is 36, and 1 times 4, which is 4, and we have a t on the left-hand side. On the right-hand side, we have 2 times 12, which is 24, and 3 times 1, which is just 3. So now when we multiply by the LCD, what you'll notice happens is that these coefficients and this constant here will divide out nicely into a whole number. 36 divided by 4 is 9. We have the t as the variable, and 24 divided by 3 is 8. So now this is a one-step equation, and all we need to do is divide by 9 on both sides of the equal sign, and we get t equals 8 over 9. And this is our final answer. So let's take a look at example 2. And if we have any terms that are not written as a fraction, we're going to go on ahead and write them as a fraction. So 3 over 1 times y. The least common denominator in this case, or the least common multiple of 1, 4, and 2 is 4. So we're going to multiply each side of our equation by the LCD. So one thing to remember is that we have to distribute when we have two or more terms inside our parentheses. So now we have 4 times 3, which is 12y over 1. 4 times negative 3 is negative 12 over 4. And on the right hand side we have 4 times 1 over 2. So now, again, just like in the last example, we can nicely divide these fractions out to give us whole numbers. So we have 12y minus 3 is equal to 2. And now this is a two-step equation, and let's see what we get for y. So we're going to add 3 on both sides. I'm going to continue up here. So we have 12y, this cancels out, is equal to negative 1. Okay, I can't read my own signs here. We're adding 3 on both sides, so we have 12y is equal to 5. And when we divide by 12, we get y is equal to 5 over 12.